Hello viewers, welcome to my channel. In today's lesson, we'll be picking up from where we stopped on the basic arithmetic of surd. In our previous videos, we've worked on the addition and subtraction of surd, multiplication of surd, and surds in brackets. If you're joining us for the first time, I'll be dropping the link to these videos in my description box below. So for today, our focus will be on the division of surds and rationalizing the denominator of surds. So let's start with the first one, which is the division of surd. Then from division of surd, we'll move into the rationalization of surds. So for division of surd, we have to take note of this. It says you divide whole number with whole number and surds with surds. So this depends on the kind of question given. If the question comes with whole numbers and surds, we first of all divide the whole numbers together, then we'll move with surds with surds. But there's no whole number in the question. You can just focus on dividing the surds with surd. So before we move into the calculation part of this class, we have to recall the division rule of surd. So I listed two rules here, and we also have other rules of surd, which we have discussed in the introductory video of this topic. I'll be dropping the link to that video in the description box also. So now, let's work with the first rule here. It says root p over root q is equals to the square root of p over q. So it's more like saying if we have surd for numerator and we also have surd in the denominator, you can work with one surd and bring the numerator and denominator under the surd, like inside the surd. So let me work with numbers. Let's say we have root 2 all over root 3. So we can just decide to bring it together. So it becomes 2 over 3. I'm just working with these numbers. I don't know if we can actually simplify something like this. I'm just working with it. So you see what this first rule means. So now let's go to the second part. The second rule here says a root p all over b root q. So this comes with this rule that says divide whole numbers with whole number and surds with surd. So whole number here is a over b. Then the surd here is root p over root q. So we'll bring the whole numbers together and then work with the surds together. So we split it here and it becomes the whole number a over b. Then the surd under the same root p over q. So let's work with numbers and let's see what we'll have. Let's say we'll have 6 root, let's say 15, okay, all over 3 root 5. So we can work with the whole numbers together. It becomes 6 over 3, and then the root, to bring it together, it becomes 15 over 5. Whereby if we break this further, it becomes 6 over 3 gives us 2. Root 15 over 5 gives us 3. Yeah, something like this. So now let's move to the example and solve the question we'll have on the screen. So for number 1, we'll have root 18 over root 2. Solutions. Number 1, we'll have root 18 over root 2. So we're going to be using the first rule I listed in the first slide, where we'll have root p over root q. You bring them under the same square root. Then you bring the numbers, that's the numerator over denominator, that's p over q. So now we're going to apply this rule to question number 1 because it has no whole number, just surds. So for number 1 here, we'll have root 18 over root q. We'll bring it under the same square root. Under the same square root, we'll be having 18 over 2. So it is now very easy for us to divide because 18 over 2 should give us, when we divide 18 by 2, it should give us 9. And here we'll have the square root of 9. The square root of 9 will give us 3 because 9 is a perfect square. 3 times 3 gives us 9. So the square root of 9 is 3. So for number 2, we have 3 root 21 all over root 7. So now we are going to be applying the second rule here, which says whole number with whole number, surds with surds. But you'll be like, okay, there is whole number at the numerator, but there is no whole number at the denominator. We can actually use this way to actually do it. Let's assume there is a invisible one here. Yeah, if we assume there is a invisible one here, we'll be having 3 over 1 as the whole number, and then we'll have the surd root 21 all over root 7. You know, 1 root 7 is still the same as root 7. Yeah, that means root 7 appeared only once, and instead of writing 1 root 7, we can just write root 7 because 1 is actually invisible. It's more like saying 1x is equals to x. Yeah, in algebra, we don't write 1s, you just write x. So it also applies to surd. Instead of writing 1√7, you just write √7. So me introducing this is because I want us to be able to split them whole number with whole number and surd with surd. So now let's split it. The whole number here is 3 all over 1, and then the surd, we can just say times the surd. For the surd, we'll have √21 all over √7. This is equal to 3 divided by 1 gives us 3. Let's write it. Times, we'll bring this under the same square root. So all in square roots, numerator 21 divided by the denominator, which is 7. So now this gives us 3. No need for us to write the times. Let's just introduce the surd. So 3 roots 21 divided by 7. 21 divided by 7 is 3. So now this gives us the final answer as 3√3. I hope this is well understood. So let's move to question number 3. So for number 3, we'll have 4√72 all over 2√8. Number 3, 4√72 all over 2√8. Okay, this is very easy for us to split. Whole number with whole number, surd with surd. So the whole number here is 4 all over 2 times the surd is √72 all over √8. So now 4 divided by 2 gives us 2. Let's write it 2. And then we're going to bring the surd under the same square root. Times under the same square root, we have 72 all over 8. So this is equals to 2 roots. We have 72 divided by 8. That should give us 9. So 9 is a perfect square. We can get the square root of 9. So what is the square root of 9? The square root of 9 is 3. So 2 times 3 gives us 6. So 6 is the final answer for this question. So now let's move to question number 4. For question number 4, we'll have 6√20 all over 3√10. Number 4, 6√20 all over 3√10. So working with the whole number to whole number, we have 6 over 3, and then we'll have times √20 divided by √10. So when we work on this, 6 divided by 3, 6 divided by 3 gives us 2. So equals to 2 times, when we bring this under the same surd, we have 20 over 10. So we have 2, 20 divided by 10 is 2. So we have 2√2. 2√2. So this is the answer for number 4. And now let's move to the final example under the division of surd for number 5. The question here says 4√3 times 2√6 all over √3. All right. So in our last video, we worked on multiplication of surd. So we're going to apply that multiplication for the numerator before we can divide with the denominator. So I hope you remember what we did in our last video. If you've not seen that, just check the description box. You'll see the link to that video. So now let's start. For the multiplication, just like the division that says whole number to whole number, surd to surd. So that way we're going to be multiplying the numerator, whole number to whole number, surd to surd. So the whole number here is 4 and 2. So we're going to say 4 times 2. We'll put it in a bracket, then we'll have the surd in bracket also. For the surd, we have √3 times √6. √3 times √6. Then our denominator will have √3. So multiplying what we have at the numerator, we have 4 times 2, which will give us 8. Then for the surd, we have to bring it together. Just like we are doing with the division, we are also going to apply that to the multiplication. So now 3 times 6, we bring it under the same square root. 3 times 6, all of our denominator, which is √3. So now this is going to give us 8 root. 3 times 6 gives us 18 all over √3. So now just as we did in example 1, whereby we'll have our root 3, we can actually put 1 here so that we can work with whole number with whole number, surd with surd. So this is 8 over 1 times root 18 all over root 3. So 8 over 1 is the same as 8 times, when we bring the surds under the same square root, 18 over 3. So this leaves us with 8 roots. 18 divided by 3 gives us 6. So our final answer here is 8 root 6. This is the last example under the division of surd. And now before we move to rationalizing the denominator of surd, I want us to take a look at this. So in a situation where we have 2 all over root 3, and we are meant to simplify this, like to work on this, is it possible to divide? No, this is whole number and this is surd. So we cannot divide this. Or maybe we also have something like root 2 over root 3. Can we divide this? It's not possible, because even if I say let us bring it under the same surd, 2 over 3, we cannot break this down and to still give us fraction or to give us a rational number. If we decide to break this down to give us decimals, and for surd we do not work with decimals in the square roots. So how do we do this? That is where rationalizing the denominator of surd comes in, whereby we multiply the numerator and the denominator with the denominator that has the surd. This denominator here has root 3. So we multiply numerator and denominator by that root 3. That way we are rationalizing the denominator. So let's go to rationalization of denominator of surd. So here we have 3 over root 2 cannot be simplified. Yeah, with what I just explained, you should know that it is not possible for us to simplify 3 all over root 2. So this will lead to rationalization of the denominator. So if a fraction has a surd on the denominator, just like this, 3 over root 2 and the other examples I explained before now, it is usually best to rationalize the denominator. Yeah, you saw how I rationalized that. So let's take our explanation further. It says to rationalize the denominator means to make the denominator into a rational number. Yeah, if you look at this example here, I say, I told you that we have to multiply the numerator and denominator by the surd. If I multiply the denominators together, root 3 times root 3 is the same as root 9. And what is the square root of 9? 3. It has given us a rational number. That means whole number for the denominator, no more surd. So that is what we want to say here. It says to rationalize the denominator means to make the denominator into a rational number, that is whole number. To do this, multiply the numerator and denominator of the given fraction by a surd gotten from the denominator of the fraction. So we have to get the surd from the denominator of the fraction. This is why I'm saying it must be a surd, because some question can actually be 2 all over 2 root 3. You don't have to go and rationalize and say you want to multiply by 2 root 3 over 2 root 3. No, it's not possible. Fine, you'll be like, but we got it from the denominator. Yeah, I know, you actually have to work with only the surd. So it's supposed to be 2 over 2 root 3 times only the surd, root 3 over root 3. This way it is correct. So we have hence. Let's look at this. So what I explained with numbers there, I'm actually going to explain it with letters there. If we have p all over root q, it is the same as multiplying the numerator of p over root q by root q over root q. So the numerator and the denominator must be multiplied by the surd in that denominator. So p over root q is going to be multiplied by root q over root q. So now p times root q for the numerator, p times root q is going to give us p root q. That's whole number times the surd, p root q. And then the denominator, root q times root q, is going to give us just q. Because if I say the square root of q times the square root of q, which is going to give us the square root of q times q. And what is q times q? Is equals to square root of q square, whereby square cancels square root and we are left with q. So the denominator is going to be just q. So that way the denominator of this surd has been rationalized. And what do we mean by rationalization? Making the denominator whole number, or we call it rational number. So let's move to the examples we are going to solve in this video. So for number 1, we'll have to rationalize. So the heading of this questions is going to be rationalize the denominator of the following question. Rationalize the denominator of the following question. So the first thing we are going to rationalize here is 6 all over root 3. Solutions. Number 1. We have 6 all over root 3. And you know the rule of rationalization. Multiply numerator and denominator by the surd gotten from the fraction. So the surd we are getting from this fraction is root 3. So we are going to multiply 6 over root 3 by the surd we got here, which is root 3 all over root 3. So now numerator times numerator, denominator times denominator. So the numerator here is 6 times root 3. So 6 times root 3 is going to give us 6 root 3. And then the denominator, root 3 times root 3 is going to give us 3. You know, root 3 times root 3. Bring the surds together. 3 times 3. 3 times 3 gives you what? 9. What's the square root of 9? The square root of 9 is 3. So that's how we got that. Let's erase this. So now we have whole number in the numerator, whole number in the denominator, and then we'll have our surd 3 at the numerator. So what we're going to do, we have to work with whole number, then the surd at the numerator. So this is 6 all over 3, whole number with whole number. Then let's leave the surd at the numerator. So 6 divided by 3 is going to give us 2. So 2 root 3 is the answer for number 1. So this surd 6 over root 3 has been rationalized to 2 root 3. So for number 2, we have 7 all over root 18. Number 2, 7 over root 18. So if we take note of the denominator of this question, root 18, it is a single surd, which has to be reduced to a basic surd. We actually worked on this on the introductory video of this topic, where we reduce single surd to basic surd and building basic surd back to single surd. The link to the introductory part of this topic is on the description box below. You can access that video if you're joining us for the first time. So now, how do we reduce root 18? Remember, what we are asked to do in this question is to rationalize the denominator. But before we rationalize the denominator, we have to break that single surd to a basic surd. Now you ask, how do you know that is a single surd? Oh yeah, we can actually get a perfect square from root 18. And when we get a perfect square, we have to bring it out and be left with a simple surd that can no longer be simplified. So let's move ahead. So now we have 7 all over root. For 18, we have to look for the factors of 18, whereby 1 is a perfect square and 1 is a simple number. And what are the factors of 18 that will give us one perfect square? It is simply 9 times 2, because 9 is a perfect square and 2 is a simple number. So now we have 7 all over, we have to split that surd, root 9 times root 2. So this becomes 7 all over. What is the square root of 9? The square root of 9 is 3. And then we'll have our root 2. So this is now a basic surd. It's been simplified. So now we can move forward and rationalize the denominator. And what do we say about rationalization of denominator? It is multiplying the numerator and denominator by the surd we got from the denominator, not the whole number, just the surd. So just the surd here is root 2. Yeah, just root 2. So we are going to say times root 2 all over root 2. So this is equals to the numerator 7 times root 2. We have 7 root 2 all over. Then we'll have 3 root 2, 3 root 2 times root 2. For the denominator, 3 root 2 times root 2. So now for the numerator, we'll have our answer there, 7 root 2 all over the denominator, 3 times. Now we'll have root 2 times root 2. Root 2 times root 2 is going to give us root 4. And what is the square root of 4? The square root of 4 is 2. So now we have times 2 here. So we have 7 root 2 all over. 3 times 2 gives us 6. So our answer here is 7 root 2 over 6. Or we can actually put the whole numbers together and say 7 over 6. Then we'll have our root 2. So either way you leave your answer, any of them is correct. So now let's move to question number 3. For question number 3, we'll have 5 root 7 times 2 root 3 all over root 45 times root 21. So number 3, we have 5 root 7 times 2 root 3 all over root 45 times root 21. So for the numerator, we have to work with multiplication of surd, whereby we say whole number with whole number, surd with surd. So the whole number here will have 5 times 2. We put it in a bracket. Then the surd will have root 7 times root 3. This is for the numerator. For the denominator, we'll have root 45 times root 21. The reason I don't want to simplify root 45 and 21 yet is because I want us to cancel something at the numerator. Because you'll be like, 45 is a single surd. Why don't we just, break it down to basic surd? We'll get there. So now for the numerator, now we'll have 5 times 2. It's going to give us 10. Root 7 times 3, if you bring them under the same surd, 7 times 3, it's going to give us 21. All over root 45 times root 21. So you see, numerator, root 21 cancel root 21 at the denominator. So we are left with 10 all over root 45. So root 45 being a single surd, we have to break it to a basic surd. So now 10 all over root 45. I'm going to bring out 9 times 5 as the factors of 45. So 10 all over root 9 times root 5. Remember, you have to split it. So we have 10 all over. What is the square root of 9? The square root of 9 is 3, and then we'll have our root 5. So rationalizing the denominator of this surd is going to be, you are multiplying the numerator and denominator by the surd in the denominator of that fraction. So times root 5 over root 5. So 10 times root 5 is going to give us 10 root 5 all over 3 times root 5. That's 3 root 5 times this root 5 here times root 5. Our final answer should be 10 root 5, which is the numerator, all over 3, the whole number here. Then the surd will have root 5 times 5. They are all in, we are bringing them under the same root. 5 times 5 is what? 25. Now, what is the square root of 25? The square root of 25 is 5. So we have 3 times 5. Now we are left with 10 root 5 all over 3 times 5 is 15. 15. If you look at this question, you will see that we can break the 10 over 15. We can break it to a more simpler number because we have a factor there. 5 can go in the numerator, 5 can also go in the denominator. So let's separate them first, just as we did with example 2, whereby we say let's separate the whole numbers and then keep the surd separate. So we have 10 over 15, then the surd root 5. So we can break this. 5 here is 2 all over 5 in 15 is 3. So we have 2 over 3, then the surd 5. This is the answer for question number 3. Now let's move to question number 4. For question number 4, we have 3 root 2 plus 2 root 3 all over 4 root 2. Question 4, 3 root 2 plus 2 root 3 all over 4 root 2. So looking at this question, please don't rush and add the whole number to whole number, surd to surd in the numerator. It doesn't work like that. Fine, it works like that with multiplication, but not like that with addition. For addition, before you can add surds together, they must have the same number in that square root. And looking at this one here, we have root 2, root 3. They are not like surd, so we cannot add them together. So what we're going to do, we're going to do straight up by rationalizing. We're just going to, immediately rationalize the denominator. There is nothing to simplify here. All the surds in their square roots are simple numbers. They do not have a perfect square in them. So you just have to rationalize immediately. So now we have 3 root 2 plus 2 root 3 all over 4 root 2. So the surd in the denominator is root 2. So we are going to times numerator by root 2 and denominator by root 2. So now we have to multiply. So for the numerator, we have 3 root 2. We have all this 3 root 2 times root 2. We have to take that one first. 3 root 2 times root 2. So let's bring it here. 3 root 2 times root 2. And then we'll have plus, I'm going to use a very big plus so we can split them. And then we'll have 2 root 3 times root 2. 2 root 3 times root 2. Then our denominator will have 4 root 2, 4 root 2 times root 2 times root 2. So now we are left with 3 root 2 times root 2. Root 2 times root 2, you bring it together. Let's write the whole number first, 3. Then root 2 times 2, that's all in the same root. 2 times 2 is what? 4. What's the square root of 4? 2. So this is times 2, and then we'll have plus, let's write the whole number first, 2. And then we'll have root 3 times 2. Bringing them under the same root, we have root 3 times root 2. So when we bring them under the same root, 3 times 2 is going to give us root 6. So this is not a perfect square. Just write our root 6 back. Root 6, then all over 4, the whole number. Then the root 2 times root 2. Root 2 times root 2 is root 4, which will give us 2. So times 2. Then we are left with 3 times 2 is 6 plus 2 root 6 all over 4 times 2 is 8. So we can decide to, bring out what is common in the numerator and denominator. In the numerator, 2 is common with the denominator. So bringing out the 2 that is common, we'll be having 2 in a bracket. 6 divided by 2 gives us 3. 2 divided by 2 gives us 1. So plus 1 root 6, which is just root 6. We close the bracket all over 2 brackets. 8 divided by 2 is going to give us 4. So 2 cancel 2. So our answer here is 3 plus root 6 all over 4. I hope you see what just happened here. 2 can go here, 2 can go here, and 2 can also go here. So when we remove the 2 in 6, we'll be left with 3. When we remove the 2 in 2 root 6, we'll be left with just root 6. That's 1 root 6, which is the same as root 6. And then we remove the 2 in 8, it's going to give us 4. So this is the answer for number 4. Now let's move to the last question in rationalizing the denominator, and also the last question in this video. So for question number 5, we'll have 12 all over root 24 minus root 6. Number 5, 12 all over root 24 minus root 6. So for the denominator, we have to simplify that subtraction first. Then after simplifying that, that's after subtracting, we can now rationalize the denominator. So we'll have 12 all over. Root 24 needs to be simplified to a basic surd. And in root 24, we can get 4 times 6 as its factor. Then we'll have our minus root 6. So now this is going to be 12 all over the square root of 4. You know what? Let's split it first. Root 4 times root 6. Then let's not forget our minus root 6. So this is going to be equals to 12 all over. The square root of 4 is 2. And then we'll have our root 6. Then minus root 6. So let's say there is an invisible one here. Now we'll have the numerator to be 12 all over. I always relate this to algebra. It's like saying 2x minus 1x. This is going to give you 1x, just x. So the same thing applies here. 2 root 6 minus 1 root 6 is going to give you 1 root 6, which is just root 6. So now that the subtraction has been simplified, we can now rationalize the denominator. So we'll multiply numerator and denominator by root 6. So 12 times root 6 is giving us 12 root 6. And then the denominator, root 6 times root 6 is going to give us just 6. 6 times 6 is 36. And what's the square root of 36? 6. So now we have to, break the numerator and denominator. I think something is common. So if we have 12 all over 6 and then we'll have our root 6, our final answer is going to be 12 over 6 is 2. So 2 root 6. This is the answer for question number 5, and this is the last question in this video. So if you have any question concerning all what we've been doing so far in Sword, we've actually worked on so many subtopics. Yeah, we can range them from, breaking single sword to basic sword, and then building basic sword back to single sword, addition and subtraction of sword, multiplication of sword, swords in brackets, even the rules of sword. And now today we actually worked on division of sword and rationalizing the denominator of sword. So these are so many subtopics under sword. So if you have any question you might want to ask Festa, you might want to ask me, drop it in the comment section. I will attend to them one after another. So just drop any question as much as you can ask. I'm willing to assist us on this journey of, knowing some topics, like breaking complex topics to simple topics. I'm really there for you. Like, I'm actually going to guide you, lead you from the simple topic to the complex topics. So thank you very much for always coming back to my videos, like, coming back to my channel, watching my videos, learning with me, solving mathematical equation and expression with me. This actually means the world to me. Thank you very much for joining me in today's class. So subscribe to our channel, turn on the notification bell so that when I drop my next video, you'll be the first person to see it. So take care of yourself and bye-bye.